All right, this is Devlog 4, Part A for Astral Chronicles. I was tasked with making the AI, so let's show you this. So let's start off by running our game. And again, I am just going to cut through encounters just to make it quick. So we enter combat. So with our combat, we can activate buttons. Let's do this. So sorry. To begin with, when somebody begins combat, there's a roll. So it is our turn to go first. So we have a logging system. So the player began combat with the enemy. And then you just saw me activate tier 1 laser. So I activated the laser, dealing 350 hull damage. And then they responded by doing using OP laser, doing 500 damage. There isn't a whole lot of abilities, so it's always going to be OP laser, but I could it that is the best choice for the AI, and that's why it's using this. So as you can see, I can swap between the two, shooting them. I get attacked as well. They take their damage, and you can see how we attack, they attack back. So for the AI decision making process, we're using a MiniMax algorithm. So let's take a look at that. So um, it is structured in a tree. So we have our nodes of a generic where we would pass in a like the encounter states, and we also have the tree of the type the encounter states. We have some functions. We have pass in the functions that will evaluate the leaf nodes, and also a function to generate children. Just because each state in different games, I tried to make this class a full generic so I can use this in other places. So this could be switched to an interface. I may do that. We'll see. But essentially, we have to pass in two functions. Function to evaluate the leaves and the function to generate multiple children. So I used func delegates wrappers to do this, and I'll show you that in the future. So we have our get best move. So this function will return the best state to pick for the enemy to reference, like to that is the best state that they should act on. So when we call get best move, we're going to generate a tree, which is going to recursively generate like tree branches until we reach the depth that we require. So the reason why we pass in functions is because, again, generating children can be unique for different types of states. So the generate children function will call whatever we pass in to generate different types of states. So then when a new child is made, we recursively like generate more and more children of the tree until we reach the zero depth. After we generate the tree, we want to evaluate the the actual tree now. So this is just like setting up the min-max to get the best value. Here is we're going to go through all of the children nodes and call our MiniMax function. What our MiniMax function does is it's going to go down the tree until we reach a leaf node. When we reach a leaf node, we're going to evaluate the state. Evaluate state is a function that we passed in because each state could be different from game to game. If we're so then we'll return a score value. This is going to recursively move like to the next one, or like go down the branch. I'll show you a diagram afterwards, but essentially we're going to keep on going down the tree, returning the score of the evaluated states to here, right? So we're going to get the score for each of the root's children. And then we're going to compare that to like our best possible score. So if the maximizing player, it's going to have a negative infinity value. So it'll always try to beat that. And then with if it's not the maximizing player, it's the same thing, but with the max value. It's just going to try to be worse than that. And it will successfully return an encounter. So where we decide our attack for the enemy, first we want to make sure that we have a ship to target and we actually have weapons to shoot. Then we want to make a deep copy of our actual current states, where here you have the best states. And then we want to make the tree class where we pass in the base states, and also if we are the maximizing player. We then want to pass in the functions. So here we're passing in the heuristic evaluation and get possible states, which is unique to the state class. We'll look at that later. And then once we do that, we can then get the best move. From the best move, we will get the last weapon that was used, because in our action log, we see the last weapon that was used. So if it doesn't have that weapon, then we throw an air just in case. And then we call the instance to activate that weapon. So this is when things will actually happen, because we simulate a lot of fights inside of the tree. For our heuristic evaluation, it's very simple right now. I'm sure this can be expanded on, but it's just a health advantage, essentially, just to see like the most health remaining for the maximizing player, right? If it is the maximizing player, then the health advantage will be set to a positive value. If it is not, it's going to be a negative value. For getting the possible states, this is where like we create the logic of like making the children. So here, the way we have decided that each possible state is us using a different weapon. So we cycle through our list of weapons. We create, again, a deep copy of that state, the new state. We then apply damage to that new state. So only that this new state variables get changed, not the actual gameplay that happens. We will then log it, so we have a record of what happened. We update the encounter state, which is the new state, and then we add this as one of the children's states. So that now that is one of the possible states, and we do that for every weapon. So we get, with this, back to Unity, a fully working min-max algorithm. It will always evaluate, it will always pick the most optimal, my bad. It will always pick the most optimal weapon. So they began combat and they use the OP laser. If we actually look at this, they only have two weapons, the dinky laser, which doesn't do a whole lot, and the OP laser that just does more. And I just did that there to like have large contrast for testing. And then, as you can see, they damage us back. Now, this is what is happening. I'm only really going to go down one side because it's the exact same thing. But essentially, we generate the tree, right? That's the first step that we want to do. And then once we have the tree, we want to evaluate all of the leaf nodes. So all of these are the leaf nodes. These won't hold a value. These won't have a score. So we use our function that we passed in to evaluate a like a score. And that score for this would be 650, right? This one is 250, 550, whatever. So then we compare the two. This is the maximizing player. So the maximizing player wants the highest value. So they're going to pick 650. This is the minimizing player, so they're going to want to pick the lower number because they're trying to, I guess, lose unintentionally. So they will pick 550. And then the root or the base state, the maximizing player who generated the tree will then pick between 550 and 150, and they want the higher value. So they will follow this path all the way to here because this has the greatest value between all of the possible states. And these numbers are tested with the actual gameplay. And that is the min-max algorithm.